Good morning, fifth graders. I know it's very rare. The Ms. H, actually, it's never happens. It's not just rare, it never happens. Ms. H is never teaching on Saturdays. However, I'm getting prepped for Google Classroom to roll out on Monday. So if you are watching this live right now, this is going to be posted into Google Classrooms. So you absolutely do not have to sit and watch it. That is not the expectation. It's just that after trying different avenues, me going live is in fact the best way to get stuff posted. So I'm just going to do that. For those of you who subscribe and somehow like get a notice, I think that I am live. I in no way expect you to be watching right now. Okay, so this is the first of the 3 lessons for the coming week. I believe this is week 6 of distance learning. I spent quite a bit of time on the last lesson because it was our first lesson on metric system. It was pretty brand new. And so, like I said, I think it was 27 minutes long. It was a pretty long video. And that was on converting metric units of length. Today's video, as well as the following days, are going to be much shorter because, as I mentioned, unlike customary units, metric system, the only thing that changes out really is the units. So you're going to see pretty much the same thing that I introduced with metric, can't talk here, units of, see, that's what happens on a Saturday. Metric units of length, exactly what we did, except you're changing it out. Instead of using meters, we're just going to substitute the word grams. Okay, so you'll see behind me, I have it, sorry, hard to see with the glare, but you'll see behind me, we've got milligrams. So instead of millimeters, which was the last one, it's milligrams. Centi is going to be our same prefix here. So milligrams, if you recall, there were 1,000 milligrams, 1,000 millimeters in 1 meter. Same thing here. There are 1,000 milligrams in a gram. Centigrams, there are 100 centigrams in 1 gram. Then we go to decigrams. There are 10 decigrams in a gram. Then we go to decagrams. There are 10 grams in a decagram. 10 decagrams make up a hectogram, and 10 hectograms make up a kilogram. Okay, so in terms of the process we are using to convert these measurements, let me move that over with the glare and readjust. In terms of the process, how to do those conversions is going to be exactly the same as the last lesson. So I'm going to kind of breeze through this in the hopes that you caught on, and I also don't want to bore you. In terms of thinking, what are we talking when we talk mass? You'll see units of mass. That is not to be confused with weight. Okay, mass is how much matter is in something. We covered that, believe it or not, way back when we studied matter. I believe it was the first quarter, if not the second quarter of the school year in science. Mass is the amount of matter that is in something. So if you recall from science, we were talking molecules, and we had pictures of all of those little molecules packed in tight, especially when it's a solid. When it's a liquid, the molecules spread out a little bit more. That's when we were talking matter. So again, mass has to do with the amount of matter that is in something. Purple box, because you know I'm always going to reference the purple box. If you go to, so this is, by the way, chapter 11. It is lesson 12, converting metric units of mass. Just to give you some perspective, since I was able to use my my measuring tape the last time. So when we are talking, like, what roughly is a milligram? A milligram would be like a breadcrumb. That is just how tiny a mass we're talking when we're talking milligrams. When we are talking grams, they show the paper clip. So kind of put that in your head. Okay, a gram, roughly paper clip. When we're talking a kilogram, it is going to be a loaf of bread. Okay. So that's just to give you a little bit of perspective. I'm going to just jump right into some problems rather than taking you through the example on the first page, which is page 871, simply because, again, this is really kind of a repeat. So I'm going to do number 9. Number 9 is taking you from a smaller unit, your grams, and you are going to a bigger unit, kilograms. So number 9 shows, tilt this a little bit. Number 9 shows 3,100 or 3,100 grams. And we want to know how many kilograms that converts to. Okay, so we are going from grams to kilograms. So we're going to follow the arrows on the top, not the arrows on the bottom. You can see that each time we're going to divide by 10. So we're dividing by 1, 2, 3 units of 10. Now, if you did not check out my video on metric units of length, the cool thing about the metric system is that it is based on units of 10. Okay, and so that makes converting so much easier. And what I did was I also took us back to when we learned to divide and multiply by powers of 10, which when you do it, you can just move the decimal point. So again, if you did not check in on my metric units of length video, if you need more detail, go and look at that because I'm not going to really go over it here since it's already in that video. So if we are dividing and we're dividing by 1, 2, 3, you're going to say 3 zeros gives me 1,000. So we're really taking 3,100 and we are dividing by 1,000. Now, if we were just going grams to decagrams, we would only divide by 10. If we were going from grams to hectograms, we would divide by 1, 2. What power of 10 has 2 zeros? 100. So that's where I'm getting that from. Okay, now rather than doing this long division, however, this is where I'm going to ask you to draw upon your knowledge of what we discussed when we learned to multiply and divide with powers of 10. All you have to do is move the decimal point. The biggest thing is, are we moving it right or are we moving it left? And we said if you multiply M, you go right. R, that's kind of the acronym that we came up with, MR, Mr. If you are dividing, you're going to move your decimal point left, and you move it the number of zeros that are in the power of 10. So in this case, we've got, I'm going to get a different color out here for you. In this case, we've got 3 zeros in our divisor. What I had you do, and this would be very helpful here, is if you write this linearly meaning in a line, just visually, it makes it a little bit easier for you to do this problem rather than looking at it like this. You're going to take 3,100. It is understood that our decimal point is here in the number 3,100. Now, because we're dividing, we're going to move our decimal point left, and we are going to move it 1, 2, 3 scoops to the left because of the 3 zeros in our divisor. So we're going to go 1, 2, 3. What this means is 3,100 grams is the same as 3 1/10 kilogram. So when you are going from smaller units to bigger units, your decimal point, provided you're using multiples of 10, your decimal point is going to move left. What happens then when we are going from bigger units to smaller? By the way, that was the answer to number 9. Answer to number 10 coming up. We've got 5/100 of a kilogram equals how many grams? All right, follow the arrows. Kilograms to grams. We are moving it how many powers of 10? Well, 10 times 10 times 10 gives you 1,000. But because we are going from bigger to smaller, you can see we're multiplying each time. You could, if you wanted to, say, I'm going to take 0.5, I'm going to multiply by 10. Take that answer, multiply by 10. Take that answer, multiply by 10. But honestly, it's just creating a whole bunch of work for you, and I don't want you doing a long multiplication in this case anyway. So let's just set up the problem. We know we're going to take 500 kilograms. We said we have to multiply in this case because we're going bigger units to smaller, and we are multiplying it by 1, 2, 3 zeros, which is 1,000. Rather than do long multiplication, whenever we do multiply with powers of 10, you move the decimal point right, the number of zeros in this second factor. So here it is. We're going to go 1, 2, 3. That means a 0 is going to go here. And so our number is going to be 50 grams. That's the way it's done, the easy way. Just to help you out a little bit more, I will do number 19 on page 874, and then we're going to be done with this lesson, folks. So number 19 gives you a graph, and it states we are looking at the we're looking at macaws and the mass of macaws, and number 19 pertains only to yellow-colored macaws. So they are saying, and a macaw, by the way, macaw is a bird. Do you like my imitation? I know you do. And a yellowtail macaw, it says, is 250. Look at the top of the chart because it shows you grams. Okay, you'll notice in this chart, the grams is not listed by the number. You have to look up here to see, oh, they're using measurements of grams. However, the question wants to know how many yellow-collared, not even yellow-tailed. What is my problem? Let's just call them yellow-collared macaws would have a combined mass of 1 kilogram. All right, to figure this out, I find that the easiest thing to do is to first, let's look at the conversion of grams to kilograms. How many grams are in? They're saying 1 kilogram. 1 kilogram, as I mentioned, is 1, 2, 3. So 3 groups of 10, when you multiply together, is 1,000. There are 1,000 grams in 1 kilogram. Again, let me look at the purple box. The purple box does indicate that. The good thing about the purple box, what I do like, is that it hones in on what you're mostly going to be using, which is grams, milligrams, kilograms. You could throw centigrams in there as well. Deci, deca, hecto, we teach you that just so you understand the process, but otherwise you really don't use that in real life. So how many yellow-colored macaws are going to give us 250 grams or 1 kilogram, which we said is the equivalent of 1,000 grams. So we want to go from 250 to 1,000 grams. All we're doing there is we're saying, well, how many 250 birds are going to get us to 1,000? It's going to be 4. If you don't know that off the top of your head, you're taking 1,000 and you're dividing it by 250. So it's going to be 4 yellow-collared macaws. And that is going to be your label. Hope that was nice and simple. Watch out, because my next video, which is going to be, let's see, we did metric units of length, we did metric units of mass. So similar to customary, the only thing left is metric units of capacity. That will be my next video. All right, hang in there, and I'll be uploading this to Google Classroom. The cool thing is you're going to be able to pull everything off of the classroom that you need in terms of PDFs, in terms of my YouTubes. It's like a one-stop shop kind of place. Okay, see you in a bit.